I ate my Cheetos too fast. Okay. Today we're talking about tessellations. It's our last section of chapter 10. Okay. Remember, we've done our reflections, our translations, rotations, isometries, symmetry, dilations, and then now tessellations. Okay, so we've done a lot of shuns in this. But when we're talking about tessellations, y'all have seen tessellations before. Most, like if you've seen wallpaper anywhere, it has a pattern a lot of times that you can shape. It could be clothing, different tops. They have patterns of geometric figures that can be designed as be regular tessellations. And we have semi-regular, we have regular, or we have irregular. We're going to talk about those. You have all those words on your notes. But we're talking on here today about our main tessellations. Okay. Now, it says a tessellation is a planar region, is a covering of the region with one or more figures so that there are no overlaps and no gaps. Okay. So the figures actually don't overlap or gap. Their sides and vertices meet. They touch each other. So the definition implies that the sum of the angle measures around any vertex in a tessellation must be 360 degrees. Remember, 360 degrees is a complete circle. So it all has to always total to 360 degrees at every vertex, be in the center. If nothing's overlapping, everything matches up perfectly to add up to that 360 degrees. So a regular tessellation, and most of them we're talking about are going to be regular or semi-regular. A regular tessellation uses a single regular polygon to tile the region. To avoid gaps or overlaps, the angle measure at each vertex of the regular polygon must be a factor of 360 degrees. Recall that each interior angle in a regular polygon has a measure of n minus 2 times 180 over n. And I put that back up here on the top. Okay, so the first four problems that we are working with, are dealing with that. Okay, our first four that we're working with are dealing with the angle measures, whether or not it could be used for a regular tessellation. So for the regular tessellation, it's going to give us a shape, a regular polygon. Remember, a regular polygon just means all the sides are congruent. Hi, Pedro. And all the angles are congruent. Okay, so if all the sides are congruent and all the angles are congruent, then it's a regular polygon. So n in these formulas, remember, represents the number of sides of the polygon. So if it's a square, it has 4 sides. Pentagon has what? I saw 5. Hexagon has
6.
Heptagon 7. Octagon 8. Okay, so you've got your numbers of your polygons, and that's something you should know hopefully by now. Okay, our formula that we're going to have to use on 1 through 4 is we're going to have to find the measure of each interior angle of that regular polygon and see if it divides evenly into 360. If it divides evenly into 360, then it can be used to make a regular tessellation, where you just have like all squares lined up, or all pentagons or hexagons, whatever one it gives us in the problem. If it doesn't divide evenly into 360, then you say no, it's not one. Okay, so that's what we're going to do. So looking on here for number 1, 2, 3, and 4, on number 1, on page 507, it says the shape is a square. So we have a square. Okay. So for our square, square has how many sides? 4. They're all congruent. We have 4 sides. Now, do I have to bother trying to figure out the measure of each angle of a square using the formula, or should you already know what all 4 angles in a square are?
Know what 4 angles are.
What? Because each angle in a square is automatically how many degrees?
90.
90 degrees. You all should know that a square has 4 90-degree angles without plugging it into this formula. Now, I could plug it into the formula and work it out, but I shouldn't have to. Okay, so each one's 90 degrees. So remember, I said we have to make sure it can be divided evenly into 360. So if I take 360 divided by 90, I get 4. So it does divide evenly. So that means it works. So we say, yes, we could use it for a regular tessellation. If when you divide it here, you get a decimal, then that means it wouldn't work. You would end up with gaps. So then you would say no. Okay, so this is what we're doing for 1 through 4. Now, number 2, what shape does it say for number 2?
A pentagon.
Pentagon. So pentagons, hopefully we already went through. Remember, they have 5 sides. So I have the number of sides minus 2 times 180, and then I divide that by 5 to find the measure of each angle in a pentagon. So this is the formula we're working out. So I have 3 times 180, because 5 minus 2 is 3. And then that's 540 over 5. It's 108. So each angle is 108 degrees. So now I have to see if it divides evenly into 360. So I take 360 divided by 108. And we get this. So did it divide evenly?
No.
No, we got a decimal. We don't want a decimal. So doesn't work. So we say no. Okay, we cannot use a pentagon by itself for a regular tessellation. Because if we tried to use a pentagon by itself for a regular tessellation, you would end up with gaps. All the sides can't make it meet up exactly at each vertex. Number 3, what shape do they give you in number 3?
Hexagon.
Hexagon. Hexagon, we said, has how many sides?
6.
6. So I have 6 minus 2 times 180 degrees over 6. 6 minus 2 is 4. So I have 4 times 180, which is 720, divided by 6, which is going to be 120 degrees. So each interior angle of a hexagon is 120 degrees. So then I need to see if I can divide it evenly into 360, which if you know your multiplication facts at all, hopefully you know that 36 divided by 12 is just 3. So 360 divided by 120 is going to be
3.
So since it divides evenly, will it work?
Yeah.
Yes. So yes, you can use a hexagon for a regular tessellation. Okay. So we got one more left. That's like this. Number 4. So what shape is number 4? In the book,
Decagon.
what does it say?
Decagon, I think.
Decagon.
Yeah.
Okay. So deca. So you might remember how many sides that is?
12.
10.
16.
Okay. Dodecagon is 12.
Oh,
So
I had it right.
decagon is just here. Okay. So if it's a regular decagon, yeah, it's just got 10 sides. Okay. So Your formula says you take the number of sides minus 2 times 180 divided by the number of sides. So 10 minus 2 is 8. So 8 times 180. So I get 1,440. And I divide that by 10, so that would be 144 degrees for each angle. Now, we see if that divides evenly into 360, which looking at it, hopefully you should know that it's not going to, but I get 2.5. So, does it work? No. Okay. It has to divide evenly into 360 for you to be able to use that regular polygon to make a tessellation where that's the only shape you use. So if I'm just trying to use decagons, I can't do it. Now, could I have one that had decagons in another shape together? Yes. Could I have a tessellation that had the pentagons in another shape together? Yes. But to try to do it just straight by pentagons or straight by decagons, we couldn't do it. Now, we could do one that was all hexagons or all squares. Those worked. So, some of our tessellations have 2 different shapes together. And it talks about that a little bit more at the top of page 506. It says some tessellations with regular polygons can be described by consecutively listing the numbers of sides of the polygon surrounding a vertex. The regular tessellation formed by equilateral triangles would be described as 3, 3, 3, 3, 3, 3. Okay, so that sounds like a bunch of 3s, right? I want everybody looking at page 506, this picture up at the top here with the triangles, okay? With your equilateral triangles. I'm not drawing these pictures up here. You've got your book. Look at it. So what it's saying is it's picking one of the vertices in this picture. So I'm picking this one like right here, kind of close to the middle. It's saying with this one vertex, the number of sides of the shapes that go around it, there's 3, that's this triangle on the top left. 3, the triangle straight above it, 3, triangle to the right, 3, triangle bottom right, 3, triangle straight down, 3, triangle bottom left. So you're naming it according to the number of sides going around, coming into that vertex. Okay. Semi-regular tessellations are made from 2 or more regular polygonal figures with the same arrangement of polygons at each vertex. So this is what I was talking about a minute ago. You could use a decagon and another shape together to make a tessellation. Or you could use a pentagon and another shape together to make a tessellation. Because by using the 2 different shapes or 3 different shapes, you can avoid the gaps and the overlaps. But if you just try to do the one, you're going to have the gaps or overlaps. So that's what I was talking about here. They give you a picture. This one has octagons and squares. Okay, you see you have the octagons first, kind of, all the big octagons, 8-sided. And then in the center where that gap was is a perfect little square. So they were able to use the squares to fill the gaps of the octagons. So that was a semi-regular tessellation. Tessellating a plane with regular octagons and squares produces a tessellation that can be described as 4, 8, 8. So again, this is that counting thing that they talked about, the numbering system that they talk about. Pick a vertex right here on here. Okay, I'm at the bottom of this first little square. So how many sides does the square have that's going into that vertex? 4. How many sides does the octagon on the bottom right of that vertex have? Octagon has how many?
8.
8. And then the octagon on the other side of that vertex is 8. So that's where they got 4, 8, 8. That's how we do the numbering system. Tessellations that are neither regular nor semi-regular are called irregular. So we're looking back at the next section now, where we're going to have to try to classify these tessellations and talk about the numbering system. Okay, so on 5 through 10, it says use the numbering system to classify each semi-regular tessellation. All of these are semi-regular tessellations because they have at least 2 different shapes in them. This first one, I see triangles, I see squares. This second one, I see hexagons, 6 sides, I see squares, and I see triangles. Okay? This one is like the one that we just talked about. You have octagons and squares. This one here, what shape has 6 sides? What's it called if it has 6 sides?
Hexagon.
Hexagon. So this one has hexagons and equilateral triangles. This one, ooh, that's got a bunch of little sides on there. Okay, those may be dodecagons. I'll let y'all count that. Your eyes are better than mine. And little triangles. And then this one, I see squares and I see triangles. Okay, so we have different shapes, so they are semi-regular. If they're all just one shape, they're regular. So on 5 through 10, all we're doing is we're trying to figure out that number system thing. So you have to pick a vertex that you want to start with. Okay, so what I suggest, you've got your book, you hopefully got a pencil or something you're writing with, and I would actually put my pencil point or pen point, whatever you're using to write with, on one of the vertices in here and then count going around it. Okay, because if you don't like pinpoint where you're at, you'll lose your place. Okay, so I usually try to pick one kind of near the top left just to kind of keep my head straight where I'm at. So I'm going to pick right here, this point right here. So I put a big dot on there so I know where I'm at. Okay, so and then I start at the top left corner and I count how many sides each of the polygons have that meet, that touch at that vertex. And that's how I get my numbers. So my first thing that I have here to the left is a square. How many sides does a square have?
4.
4. Then my next, going to the top right, I have what? 4.
4.
Right? And then down below it, I have a triangle, so that's
3.
3. I have another triangle turned the opposite direction, so that's a
3.
3. And then I have one more triangle that meets at it.
That's a 3.
So that's 3. So I have 2 4s and 3 3s, right? Okay, now a lot of times they put them in order least to greatest. You don't really have to, you know, as you're going around. So you can start with the 3s first or the 4s first. But the numbering system would be 3 3 3 4 4. Okay? But you pick a point to start at and then count the sides of the figures that are going into it. Okay? Number 6. I'm starting, I don't know if you can see where I put my little point there, the top left. Okay? See where I'm kind of starting at? So I'm starting right here. So I've got a little triangle pointing at that on my top left. So a triangle has how many?
3.
3. And then next to the triangle, working my way around that point and going clockwise in a circle is a square. So that has
4.
4. And then down below the square at that point is the other shape that has 6 sides. So the hexagon, so I've got 6. And then next to the hexagon, I have another what?
Square.
Square, and then I end up back at the triangle I started with. So we have a triangle, a square, a hexagon, a square. So triangle, square, hexagon, square. So our numbering system for number 6 would be 3, 4, 6, 4. You have to pick a point to start at and count your way around that vertex. Okay. Number 7, I'm going to pick this vertex right here. Okay. Pick this vertex right here at the top. So right next to that vertex on the left-hand side is a square. Up above it is what shape? How many sides does that have?
8.
8. And then right below that is another octagon, which is
8.
8. And that's all that meet at that one vertex. So you have 4, 8, 8. Okay. Next one. I'm going to pick right here. Okay. So I'm starting right here. So right to the top left of that vertex, I have a triangle. Then on the right, I have a hexagon. And then below that, there's another triangle. And then to the left of that is another hexagon. So triangles have how many sides?
3.
Hexagons have how many?
6.
So it's 3, 6, 3, 6. Okay. Now on number 9, I'm going to pick this little vertex right here at the bottom right corner of that first little triangle that's in the picture. They're little itty bitty triangles. Okay. So I have the triangle, which everybody hopefully knows that's 3. How many sides are on those big ones that they have in there? They almost look like a circle, but it's actually a polygon. It's made up of sides. So you have to,
Well,
okay, he says 12. So 12, remember, is, I said it earlier, a dodecagon. So at the vertex, you have the triangle, and then it touches 2 dodecagons. So you have 3, 12, 12 is your numbering system for number 9. Okay, and then the last one, number 10. Okay, number 10, let's go right there in the middle. Okay, going right there in the middle. So straight above it is a triangle pointing down to it. And then to the right, there's a square, and then a triangle, and then a triangle, and then another square. So I have triangle, square, triangle, triangle, square. So triangles are 3 sides, right?
yep.
Squares 4, triangle, triangle, square. All right. Now, for our last 6 problems on the tessellations, it says determine whether each tessellation is regular. Remember, regular, it uses one shape. Semiregular uses 2 or more regular polygons. Or irregular, which means it doesn't use a regular polygon. Okay? So we got regular, just uses 1 regular polygon. Semi-regular uses 2 or more regular shaped polygons. Or irregular, where it's not made of irregular polygons. Okay? If it's irregular, tell why. If it's regular or semi-regular, then we have to do our numbering system thing that we just did on 5 through 10. Okay? So you kind of have like 2 answers for each one. You have whether it's regular, semi-regular, or irregular, and then the classification or why it's irregular. So looking at number 11, are they the same shape or different shapes? Everybody should be able to answer that. Is it the same shape or different, made up of one shape or a bunch of different shapes?
One shape,
All those shapes are the same?
different shape.
It's got different shapes, right? You got the two big things in the middle that kind of look like our dodecagons that we had in number 9. Then I see some little orange, darker orange squares, and then the blue things are hexagons. So I've got different shapes. All of those are regular polygons though. So it's going to be semi-regular. It's made of regular polygons, but it's made of different types of regular polygons. Okay, and then the next thing that we've got is we got to classify it about its vertices. So you pick one of the vertices. So I'm going to pick, okay, this vertex right here at the top. Okay, so to the left of my vertex is the square. To the right of my vertex is the hexagon. And then below the vertex is this big shape in the middle, which I said was a what? Dodecagon, which is how many sides?
12.
12. So I'm going to have 4, 6, 12 as my classification for the number system. So it's semi-regular because it has different shapes in it, but the classification is 4, 6, and 12. Now number 12, are all of them the same exact shape?
Yes.
Yes. So that means it's regular. And what shape is that?
An hexagon.
Hexagon. It's got 6 sides. So if you pick one of the vertices, how many hexagons touch at one vertex? 1, 2,
3.
3 of them. So if I do the number system, it's just a number. You've got 6 sides, 6 sides, 6 sides. Number 13, is it made up of different shapes or the same shape? One single shape.
Different.
It's got different ones. So then we look at it and see if it's semi-regular or irregular. So do those shapes that are in there look like they're made up of congruent sides?
No.
Like if I'm looking right here, some of those things look like they're trapezoids. Are trapezoids regular?
No.
No. So this one's going to be irregular because you have non-regular polygons in it. Not all of them are regular polygons. What about number 14? Okay, you've got like one single shape it looks like that's used over and over again. Okay, don't worry about the color. They just try to make them pretty. But you don't have to worry about that. You're looking at the shape. Okay, they all have that one same shape, but is that shape a regular polygon? Are all the sides and angles congruent in it?
No.
No. Okay, it's 1, 2, 3. It's some kind of weird shaped a pentagon, so, but it's irregular because it's got non-regular polygon. Polygon. I left out my Y. Okay. All right, number 15. Okay. Same shapes or different shapes?
Same.
They're all the same?
I see triangles.
You see triangles? What else is in there?
1, 2, 3. Hexagons.
Okay, so I've got triangles and I've got hexagons. So it's not regular it's going to be
Semiregular.
semi-regular, okay? Because I got two different shapes. Both shapes are regular polygons, but there's two different types of regular polygons. You've got your hexagons, and then you got the triangles that surround it. So when you try to do the number system, I'm going to pick the vertex here on the left-hand side of this top hexagon. So when I do that, I have a triangle that points at it from the left, another triangle that points at it straight down, then a hexagon, then a triangle that points straight up from the bottom, and then a triangle that points from the bottom left. So there's triangle, triangle, hexagon, triangle, triangle at each vertex. So triangles have how many sides?
3.
3. Triangle, triangle, hexagon, triangle, triangle. Whoops, guess I need to get where y'all can see it. 3, 3, 6, 3, 3. Okay, last one of these, number 16. What shape is used in that?
Square.
A square. So when I look at one of the vertices here, each vertex has how many squares that meet there? I'm so glad Javier is the only one who can answer me.
4.
4. So since it only has one shape, it's a regular, because that shape is a regular polygon, a square. And then 4 squares meet at each vertex. So by the numbering system, it's 4, 4, 4, 4. Okay. Now, I did see some more of you sent me your chapter 10 quiz today. I haven't got to look at it yet. I just saw it come across my email on my phone, popped up while I was teaching my other classes. So I'll be trying to work on those some at lunch. Some of you still have some chapter 8 stuff to send in, chapter 9 stuff to send in, a bunch of stuff to send in. Okay. Now, I know that we're almost done. Some of you, though, have already tried to shut down. We're not done yet. We're almost done. So please make sure you're keeping up with this stuff. Remember, if you want to send that in to me, then you need to do that as well. Otherwise, I'll have you trying to hold it up one day to the camera, and that's hard to do. It's much easier if you just take the pictures or whatever and send it in. But we'll go from there. With your with your other stuff that you owe, okay, I'm still trying to go through and figure out, because where I've gotten like so many emails, y'all wouldn't believe how many emails I get every day where people send me work. So I'm still going to spend this weekend trying to finish going through there and seeing what people owe me still and everything. So I'm not going to try to stay after today with the chapter 8 stuff, because some of you did that, like you sent me part of it one day and part of it another day, and I'm still trying to get figured out what I actually still need. So, because I tried to look at them some yesterday and they were all run together. So that's what I'm doing this weekend. Yay me, I get to work all weekend on your all stuff. So I'm going to go through, I'm going to try to see what we got from there. Okay. Now, while I am working on that stuff this weekend, you need to be making sure you've got your notes filled out that are in the orange folder, that you had actually done that Tessellations worksheet that you were supposed to have done on Monday. I did have 1 or 2 people send that into me as well. On there, all you had to do was say it was a rotation, a reflection, or a translation. Okay. I'm going to be sending out special individual things to people saying, hey, I still need this. Hey, I still need this. So I'm trying to go through and get all that caught up from you all so that you know what's going on. Okay. So please, please, please check your My Schoolworks emails so you know what you still owe me. Okay. I'm trying to go through. Javier, what are you doing? Please quit moving your arm across the screen. All right. Please, I'm trying to go through and see what you still owe me and send out individual emails for that. Now, like I said, the majority of you, I think, did your quiz and sent that in to me the other day. If you have not, I want that to be your first priority. Please send that in this afternoon. Okay? Next week, we're going to be talking a little bit more with our similar figures, and then we're getting ready for the exam. So you've got to make sure you're trying to log in on time. Some of you are always logging in late, and that makes it hard to keep up with where we're at. So please get here on time. It's at 11. Okay. I know that Miss Vargas finished with you on time, so you had a little bit of break in between there to do restroom or whatever to get here. So we've got to get where we're coming at time so we can get this stuff done. Okay. So please, please, please work on that. If you have any specific questions about something that you're missing that you want to ask me today before you leave, then you can stay on and ask me. Otherwise, work on making sure I get your chapter 10 quiz. Make sure I get your tessellations worksheet. Not tessellations, transformations, wrong T word. Make sure I get your transformations worksheet, and then make sure your notes and stuff are filled out and ready. Okay? I'm going to be trying to gradually start sending some little other notes paper type thing as attachments through the messages through my school works for you, so you'll have those kind of all in one place for when you're doing your exam. Okay? So if you've got individual stuff you still need to ask me about, you can stay on and ask me. Otherwise, I will see you all Tuesday at 11.
All right, see you, Miss.
Bye.
Okay,
Have
Miss
a good
Bella.
weekend.
You too, Miss. Bye, Michael.
He hung up on you, buddy.
Yeah, I know. I saw that. All right, Miss Pam. I turned in some of the work from the test, chapter 9, I think, or
Okay,
10.
I saw an email from you, so it was chapter 9.
Yeah, I don't remember which one it is. Yeah, but I was able to
I
turn it in.
see all my emails? See all that? Look, everywhere. All my school works. Okay, so I get them popping up on my phone during classes, but then I look at them at lunchtime and in the afternoon. So
Yeah, I'm going to be
it's
trying to.
part of one. What about the quiz 10? That one was short.
Oh, I